Casting objects. So we have already used typecasting in case of primitive types. So casting means when one type of object or one type of variable behaves like another type of variable. That is known as casting. So casting can also be used to convert an object of one class type to another, but this casting needs to be within the same inheritance hierarchy. So in the preceding section, the statement when we invoked the method M and we passed the new student, that means a student object as parameter, we already assigned an object of type student into a parameter of type object. That means equivalently, first we are creating this new student, and then we are assigning the value into the object type O, and we have seen that in this line object is the declared type of O and student is the actual type of O. And we can do this line because of polymorphism. And this type of assignment is known as implicit casting. That means this is implicit because we are not mentioning the casting explicitly. That means when a supertype object is needed, we can pass or we can use any of its subtype. And for this, we don't need to write any separate code. That's why this is implicit casting. So next, we can see that, so this student, this is known as implicit casting, and this is legal because an instance of student is automatically an instance of an object. So why casting is necessary? So let's say you want to assign the object reference O that we just created in the previous slide to a variable of the student type using the following statement like this. That means student B equal O. Unfortunately, you will see that a compilation error has occurred. But why so? Because we have seen that O is actually a student type because we created with new student. So even if O is actually a student, then why can't we assign it to a type of student, B? So this is because a student object is always an instance of object. That's why we could write this line that object O equal new student. But once this assignment is done to the operating system, O becomes a type of object. So when we want to assign here O into the student to the operating system, that's an error because O is now the type of object. An object does not have the necessary information of student class. That's why it does not allow to assign a type of O to a type of B. Okay? So even though you can see that O is really a student object, the compiler is not so clever to know it. Therefore, to tell the compiler that O is a student object, so you can actually assign O to B here, we need to use an explicit casting. And just like primitive type, explicit casting means we need to put in the type we want to cast into the parenthesis pair. So enclose, we need to enclose the target object type in parenthesis and place it before the object to be cast as follows. So we can, instead of this line, which is an error, we can write this line, that student B equals student O. So this will cast the type O to its actual type student. One important thing to note is we can cast only to its actual type. So since student is O's actual type, we can cast O into student only. So when we cast from superclass to subclass, the question is, can we do it all the time? So explicit casting must be used when casting an object from a superclass to a subclass. But this type of casting may not always succeed. For example, apple X equal casting into apple the type fruit, or orange X equal casting into orange the type fruit. This may not always succeed. Please pause this video and think about this for a few minutes, why we cannot do this. Hopefully you have come to a conclusion. So we can think of before, that means since there is a question of capability, that means we can only cast a variable into its original type. Therefore, before casting, we should check whether the type we want to cast to and its actual type matches. And we can do this by this instance of operator. So this is a Java keyword. So use the instance of operator to test whether an object is an instance of a class. So here we are creating this object, my object equal new circle. So the declared type of my object is object and the actual type is circle. After some time in the code, if we want to invoke the get diameter method from directly my object, that will be an error, because to the system my object is of type object and the object class does not have any get diameter method. So what we need to do is we need to cast the my object into its actual type circle first, and then from this casted object we can call this get diameter method. But before we want to cast it, we should always put it inside a if condition. That means if my object instance of circle, then only cast it into circle, because along these coding lines inside, the my object type can change and it can become a type of rectangle or a student. So a type of rectangle or a student cannot be casted into circle type. So we can think of this with the analogy of fruit. So to help understand casting, you may also consider the analogy of fruit, apple and orange, with the fruit class as the superclass for apple and orange. So let's say I'm giving you an apple because you wanted some sort of fruit. So you ask me, okay, give me a fruit. And I'm giving you an apple because you just require a fruit. So when you require the superclass fruit, I can give you any of the subclass like apple or orange. But let's say you have some fruit. I know that you have some fruit. That fruit can be anything, apple, orange, banana. But what I require is, specifically, I need apple. So where the fruit you have, if you give me the fruit, that may or may not be apple. If it's not an apple and you are still giving it to me, then that will be an error. So that's why before changing into some type or casting into some type, we should always check whether the actual type and the type we want to cast to matches.